So have you ever been on a project where the deadline was too tight? I think most of us would have been. Chances are that tempers were straight, sponsors were unhappy, and that members were working ridiculous hours. These are basically because of whenever we do an estimation, there is a concept wherein we try to include a lot of buffering. So what happens is if a sponsor asks his project manager, can you give an estimate for say a task A? Project manager will give it to task, his lead might give it to team member. And there comes the buffering part, wherein what a team member would say that if this task would have been done in 2 days, let's do it in 3 days. He will give it to lead will add his buffer. 5 days, manager will add his buffer, and that is what not PMI recommends. PMI recommends that you always estimate a task based on previous estimations or the scientific view of estimating. And if you have any, if you feel there are any risk attached to it, you add those risks and add those in estimates. So if I say that if this does not happen, then probably this would take X amount of hours to be made. This is how people often underestimate the amount of time needed to implement projects, particularly when they are not familiar with the work that needs to be done. So that is why it's important to estimate time accurately if your project is to be successful. In this, we will look at process for making good time estimates, and we explore some of the estimating methods that you can use. So today we are going to discuss basic 4 main methods to estimate cost in project management, that are analogous estimating, excuse me, yeah. So it's analogous estimating, parametric estimating, bottom-up estimating, and 3-point estimating. Analogous estimating, this technique is to eliminate the project cost when very little details about the project is available. So there are times when we don't know what this project will do. We just have a project charter or maybe a brief detail about the project. So therefore, this technique does not provide a very reliable estimation. But the primary benefit of this estimate is very fast. So it is done usually at an RFP stage, or when you have very little details about what you do it just with guessing by comparing it with similar project previously compared to organization. You can do it via looking into the various organizational historical records. That is what we call as organization process assets for previous completed projects. So you will select a project which has been the closest to your project. So once you get it, you use your expert judgment to determine the cost estimate of your current. However, this is not a very good way of estimation, but yes, it's very fast and less costly. The other way of doing it is by parametric estimation. This technique also uses historical information to calculate the cost estimate. However, there is a difference between this technique. It uses historical information along with statistical data. So it takes variables from the similar project and applies them to the current project. For example, in the previous project, you will see that the cost of concreting per cubic meter was how much that was, and then you will calculate the concrete requirement for your project and multiply it with the cost obtained for the previous project to get the total cost of concreting for your current project. In the same way, you can calculate the cost of other parameters, man, materials, and equipment as well. So as we've seen, like the basic difference is it is also based on historical information, but we do apply some scientific ways of calculating it, and so the accuracy of this process is much better than the analogous estimation. Now the third is the 3-point estimation. This is what is a better way of doing it from both analogous and parametric. It reduces the biases and uncertainties in estimation assumption. So what you do is, instead of finding one estimate, you basically think that what happens if everything goes as normal? What happens that, which we in this program evaluation and review technique, PERT technique, we call it as most likely cost. When we consider the worst case, and it assumes that almost everything goes wrong. And then we say, if it considers the best case and assumes that everything goes better than planned. So basically it is, and the formula which goes is like CO plus 4 times CM plus CP divided by 6. So for any work package to be estimated, so you say that Okay, my optimistic cost comes to say around 20 hours. My pessimistic cost comes around, so that is the most, so it comes around say 80 hours, and my most likely task probably comes around 60 hours. So we will do a 20 plus 4 times 60, that is 240, 260 plus 80, and then divided by 6. So that comes around 55, 56 hours. So this technique is much better than the two discussed before. Now finally coming to the bottom-up testing, estimating. The bottom-up estimating technique is also known as the definitive technique. This estimation technique is the most accurate, time-consuming and costly technique to estimate the cost. In this technique, the cost of each single activity is determined with the greatest level of detail at the bottom level and then rolls up to the calculate the total project cost. So you define the work breakdown structure, define what all those tasks are, and then you do it via bottom estimating, wherein you are you are calculating the number of hours for each activity and then further consolidate it. So this is how